Okay, to make matters even more fun, he's got a duplicate number 17 on the test. There are two 17s. So in addition to the two methods I did for the first problem 17, there's a totally separate problem, and I'm going to call this 17C. And this is the one where we have to graph this thing. So the first thing he wants us to find is the vertex. And you can always find a vertex by using x equals negative b over 2a. If we're comparing this original equation to ax squared plus bx plus c, we can see that our a is that imaginary 1 there, our b is a minus 4, and our c is 1. So if I have x equals negative b over 2a, it'll be negative a negative 4 over 2 times 1. So that's negative b over 2a. So x is 4 over 2. So x is 2. That's just the x-coordinate of the vertex. To get the y-coordinate, remember that f of x is like y. So y equals this mess. So we just need to know when x equals 2 what y is. So plug in x equals 2 to this, and y will equal 2 squared minus 4 times 2 plus 1. So putting in 2 squared minus 4 times 2 plus 1. So we get y equals 4 minus 8 plus 1, so minus 4 plus 1 is minus 3. So our vertex is at 2, negative 3. X is 2, y is negative 3. There's my vertex. Okay, so for the next step, he wants the y-intercept. And you can always, always, always find a y-intercept by letting x equal 0. So going back up to that problem, if x equals 0, we want to know what y is. So plug in 0 for the x, and we'll get 0 squared. Let's see if I can get both of it. So y will equal 0 squared minus 4 times 0 plus a 1. So basically 0 minus 0 plus 1, y equals 1. That's your y-intercept. Then, to find your x-intercept, you can always find an x-intercept by letting y equal 0. So remember our original equation was y equals x squared minus 4x plus 1. So I'm going to let 0 equals x squared minus 4x plus 1, and then solve this like normal. It's a quadratic, it's set equal to 0, so I'm going to attempt to factor the guy, but, silly guy, it is not factoring. I can't find anything that'll multiply to make 1 that'll add to negative 4, so sad. If it doesn't factor, if a quadratic equation doesn't factor, we have to use the quadratic formula. So that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to say x equals, remember, a was 1, b was negative 4, and c was 1. So I'll have negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 all over 2 times 1. So cleaning this up, that'll be 4 plus or minus the square root of 16 minus 4 over 2. So this will be 4 plus or minus the square root of 12 over 2. if I were to tree this 12, take the square root of 12 over here and tree him, that's a 2 and a 6, a 2 and a 3. It's my pair of 2's, so the pair will come out, leaving the 3 inside. So just replacing the square root of 12 with 2 root 3 in here, I'll have 4 plus or minus 2 root 3 over 2. And I can divide every single piece, magic triangle style, by a 2. So 4 divided by 2 is 2. 2 root 3 divided by 2 is just root 3. So your x-intercepts are 2 plus or minus root 3. Okay, and now he wants you to graph this thing. Now, to be able to graph 2 plus or minus root 3, while we're on here, we're just going to use our calculator. So I'm going to plug in, I'm going to find the square root of 3, which is about 1.73. So this is 2 plus or minus 1.73. So if it's 2 plus 1.73, that's 3.73. And if it's 2 minus 1.73, that's about 0.27. So those are the x-intercepts that are going to help us when we graph it. So we'll try to do that now. I'm going to graph everything that we found. So first we found a vertex, and we found that vertex was 2, negative 3. So the vertex was positive 2, negative 3. That's my vertex there. We also found the x-intercept, or we found the y-intercept first in part B. We found the y-intercept to be a 1. So it's going to cross the y-axis at 1. There's my y-intercept there. And then my x-intercepts were that lovely 3.73 and 0.27. So it's going to cross the x-axis at 3.73 and 0.27. So there, 0.27, about a quarter of the way between 0 and 1, 3.73 there. So we pretty much have enough to graph this just by the points we have. So I know that's my vertex. I know it's going to look like a little U going through there. If I needed more points, I could make an XY table and flesh it out a bit, but this, he actually has enough points, and there he is.